Have you ever looked at your home air conditioner or space heater and wondered how much energy it actually draws while it is running? Today, we will find that answer. We are going to calculate the electrical power of a standard appliance and translate that into the specific energy units you see on a monthly utility bill. This is a practical exercise, so please have a pen, paper, and a calculator ready to follow along with the math. By the end of this lesson, you will be able to predict the energy footprint of your household devices based on their technical specifications. We begin with electrical power. This is defined as the rate at which electrical energy is being consumed or converted by a device. As the highlight appears on the formula, to find power, we use a basic formula. Power equals voltage multiplied by current. Most appliances provide these variables on a specification sticker. Here, we have a device rated for 230 volts with a current draw of 5 amps. Methodical pace. Multiplying 230 volts by 5 amps gives us a result of 1,150. This value is measured in watts, the standard unit for electrical power. While advanced tasks might require using resistance-based formulas from Ohm's law, the multiplication of voltage and current is the most direct way to find the power rating of a household load. Knowing the wattage tells us how much electricity a device uses at any given moment, but to see how this affects a bill, we have to look at consumption over time. Utility companies do not measure consumption in watts. They use a larger unit, which requires a conversion to kilowatts. We take our 1,150 watts and divide by 1,000. This gives us 1.15 kilowatts. Now we can determine electrical energy. This represents the total power consumed over a specific duration of time. The formula for energy is power multiplied by time. For the math to be accurate, we must use kilowatts for power and hours for time. For example, if a 1 kilowatt heater runs for 3 hours, it consumes 3 kilowatt hours of energy. In commercial electricity, 1 kilowatt hour is recorded as exactly 1 unit on your meter. Let's apply these steps to a new scenario to verify the calculation. Suppose you have a load with a voltage of 200 volts and a current of 5 amps. What is the resulting power? Your choices are 40, 200, 1,000, or 5,000 watts. By multiplying the 200 volts by the 5 amps, the result is 1,000. Arriving at 1,000 watts confirms you can correctly identify and calculate the power consumption of a standard circuit. You now have the tools to identify power and energy metrics using nameplate data from your own appliances. Use this matrix as a final reference. It summarizes the symbols for voltage, current, power, and energy, alongside their respective units. You may want to note these symbols down for future use when evaluating electrical devices. Now that we can calculate the volume of energy consumed, our next step is to understand how that energy actually flows through a wire. In the next lesson, we will compare the behavior of alternating current and direct current and look at how their waveforms differ in practical applications.